Hi folks, Mr. Hempstead here. Plan for this week, we're going to watch this kind of review video today on Monday, and then on Tuesday you guys have your density quiz. So here we go. Let's talk a little bit about density. First of all, I'd like you guys to just kind of take a moment and think to yourself and then type into the little question box, what is density? Go ahead. So there's kind of two ways that we can think about density. We can think about it both in terms of its definition, and we can also think about it in terms of its equation. And I would accept either answer as a perfectly valid definition for density. So let's just kind of talk about the word definition first. Density is the amount of matter or stuff in a certain amount of space. So what is matter? Well, matter is just stuff. It's just atoms. This shirt is made of matter. There's a little bit of matter even in the air. There's matter in the computer or laptop or iPad that you're currently using to watch this video. Matter it's very, you can feel it, right? You can feel the wind in your face. You can feel your toes, etc. That's how you can tell things are matter. And matter takes up space. So gas takes up a lot of space. There's not a lot of particles in the air. It takes up a lot of space. But this cell phone takes up relatively very little space. There's a lot of matter packed into this little amount of space. So this phone is very dense, and the air in this room is not. Okay. The second way we can think about density is in terms of its equation. What is the equation or formula we use to solve for density? It is density equals mass divided by volume. Or you could write it as D equals M over V. There you go. Okay. Density is the amount of stuff, the amount of mass or matter, in a certain amount of space, in a certain amount of volume. Cool. Let's talk about density in some of the real-life applications that we've discussed this past unit. So the first is in the case of wood and rocks. If we take a piece of wood, frankly, it doesn't really matter what size. It can be a small piece of wood or a big log, but wood floats in water. And rocks sink in water. So why is this? Why is it that this little piece of wood is floating, and why is it that this large rock sinks? So a lot of people think it's because of mass. Well, the rock is bigger, it's heavier, it sinks because it's heavier, and the piece of wood is really small. But that's not true. See, the reason the large rock sinks is because it has more density. Let me just change the color real quick. There we go. It is more dense. There's more matter packed into this little space that is the rock. And the wood is less dense. Whatever. There we go. Okay. Even if we made this piece of wood larger, even if the wood was actually more of a log, here we can make it big, we've changed how massive it is. It's more massive, but it also takes up more space. And so it's still less dense. In fact, the large piece of wood and the small piece of wood have the same density. Okay. So let's try another practice problem real quick. We did an experiment where we had an orange with a peel and an orange without a peel. The orange with a peel was more massive, right? It has the peel on it. That adds mass to it. And the orange without a peel, here we can move this down just a little bit. Orange without a peel, it had less mass. So why is it that the orange with a peel floated and the orange without a peel sank? So just because an object has more mass or less mass, that doesn't tell us if it's going to float or not. See, the orange with a peel, you can kind of think about the peel like a life jacket. That life jacket adds some mass to the peel, that life jacket, that peel adds some mass to the orange, but it also adds volume. And what it does is it changes its density so that it is less dense. And the orange without a peel, well, it's lost that life jacket. So even though it has less mass, it is more dense. And that's just because it's more stuff in a smaller amount of space. I guess technically it's less stuff in a smaller amount of space, but even so, the density changes. It's lost that life jacket. And you can think about that with yourself as well, with an actual life jacket. If you're wearing an actual life jacket, technically you have more mass. But when you're wearing that life jacket, you will float in water because the life jacket makes your density lower. And if you lose that life jacket, you might sink in water. You could drown because you are now more dense. Just like the oranges. Kind of cool. Okay. The last thing that we learned this unit was how to solve a density problem. To solve a density problem, we used something known as the Ifsmooth method, which, here, I'll write it out for you guys. Ifsmooth stands for identify, formula, substitute, math, and units. You will need to do one of these problems on our quiz, and you will need to do all 5 steps of Ifsmooth in order to get full points. So let's talk about how we do this. The first step involves identifying what we know and what we don't know. We don't know the density. So right now density is a little bit of a question mark. But we do know the mass. It tells us the mass is 24 grams in our problem. Do we know the volume? If so, what is it? Good. It also tells us the volume. The volume is 3 milliliters. Nice. Okay, cool. What is the formula that we use to solve for density? Cool. So the formula is density equals mass over volume, or D equals M over V. Next, we're going to substitute what we know into our equation. So what will our substitution step look like? It should look like D equals the mass, which is 24 grams, divided by the volume, which is 3 milliliters. All I did was I substituted what I knew into the problem. I took my 24 grams and I substituted it in for M. And I took 3 milliliters and I substituted it in for volume. Sweet. All right, so now that we've done that, we just need to do our math. The math is fairly straightforward. You can simply take a calculator and do 24 divided by 3, which equals 8. What would our units be? Our units in this problem would be grams divided by milliliters. And we can easily see that because we included our units in our substitution step. That's extremely important. Including our units when we do our substitution lets us see what our units are when we get to the end. And knowing what units to put in our substitution step is a lot easier when we use our units in our identify step. In order to get full credit on the quiz, you need to show units anytime you write a number in one of these problems. Cool. Tomorrow there will be a quiz. It's fairly short, and then it's Thanksgiving break, so I won't see you guys on Wednesday. We won't have another lesson until the Monday after Thanksgiving break, and that'll be virtually, not face-to-face virtually, just me talking to you either through a video or an assignment. Cool. But you'll hear from me next Monday. Have a lovely Thanksgiving break. If you celebrate Thanksgiving, take care.